exponential growth and decay. When we look at the exponential function f of x equal to b raised to the x, that exponent is going to be our variable, and we have a constant as the base. The horizontal asymptote is y equals 0. So when we're identifying by the graph, exponential growth is going to grow as we follow the graph from left to right. Exponential decay, it will decay as we follow the graph from left to right. When we look at the general function, they're going to be the same, where f of x is equal to a times b raised to the x minus h power plus k. The only difference is, for growth, b is going to be greater than 1, and in decay, b will be greater than 0 but less than 1. A couple tips to remember: when you're graphing this on the calculator, make sure to put parentheses around your exponents. A is going to stretch or shrink your graph vertically. When the absolute value of a is greater than 1, it's going to be a stretch. And when the absolute value of a is less than 1, it's going to be a shrink. H will shift your graph horizontally left and right, and remember it's going to be opposite of what it seems like. So if it's minus, it's going to move it to the right. If it's plus, it'll move it to the left. K is going to shift you vertically up or down, and this one's the same sign as you see. Positive goes up, negative goes down. This will also move your horizontal asymptote. Here we want to tell whether each function represents exponential growth or decay. So remember, we have f of x equals b to the x, and if b is greater than 1, that represents exponential growth. If b is greater than 0 but less than 1, that represents exponential decay. So let's go ahead and work out these examples here. You find the exponent, and then the exponent is on our 5/3. 5/3 is greater than 1, so we have exponential growth. In example 2, here's our exponent. The exponent is on the 1/4, which is bigger than 0 but less than 1, so we have exponential decay. Example 3 and 4, they have negative exponents. So the first thing is we need to make those negative exponents positive. So remember, to make a negative exponent positive, you switch the numbers in the fraction. So the 7 is actually going to go to the bottom of the fraction into the denominator. Then that exponent becomes positive. So now when we look at our b, the base of the exponent, 1/7 is bigger than bigger than 0 but less than 1, so this is going to be an exponential decay. Example 4, again, we have that negative exponent, so we need to take the reciprocal, 3/2, to make that exponent positive. And so now 3/2 is greater than 1, so we have exponential growth. Now let's go ahead and use our calculator to help us identify the transformations, graph the function, and state the information below. Before we actually move to the calculator, we can identify the transformations based off of the parent function. Since our parent function is 3 to the x, we have to look at all the transformations that are done to 3 to the x. So we have this 2 multiplied out front, that's our a, and since 2 is greater than 1, that means we are going to have a vertical stretch by a factor of 2. So we're actually going to stretch our graph. Now we have this -4 at the end, and take note that it's not part of the exponent, it's just on at the end. So that means that we are going to have a vertical shift down 4 units. There are actually 2 more things we can answer before we go to our calculator. Growth and decay. Remember, this is based on the constant. So if you look at the constant, 3 is greater than 1, so we're going to have exponential growth. And also, the horizontal asymptote follows the vertical shift. So our horizontal asymptote is going to be y equals -4. So we can actually go ahead and plot our horizontal asymptote on our graph so that we know that our graph will get close to y equals -4, but it's not ever actually going to meet it. So let's go ahead over to our calculator go to our y equals and type in our function. So we have 2 times 3 raised to the x power, and make sure to come down off of the exponent when you type in your minus 4. And then we can graph. And then when you take a look at our graph, we do indeed have a horizontal asymptote at y equals -4, and we do have a growth function. So let's go ahead and answer our other information here. We're talking about end behavior, and as x approaches positive infinity, as we follow our graph to the right, we're going up towards positive infinity. As x approaches negative infinity, so as we follow our graph towards the left, f of x, our y value, we're actually reaching -4. So we're getting really close to that horizontal asymptote, but we're never going to meet it. So we're getting close to -4. For our domain, we will have values for every x and y. So we have -infinity to positive infinity. And for our range, our lowest value, it doesn't include -4, but it goes from -4 up to positive infinity. Now to get a few points to graph, remember, we want to go to our table and look for some nice points that'll fit on our graph. So integer values, we have 1, 2, we have 0, -2, and we actually don't have any other values that'll fit on our graph. So you can take another one and just approximate. We have -1, -3.3. So go ahead and plot those points, and those are the points that are going to help you sketch your graph. So once we have this, we know that we're getting close to the asymptote, and then use your points to help you sketch. Now I want you to go ahead and try this one on your own. Pause, and then check back with me when you're finished, and let's see how you did. So for example 6, hopefully you notice that we have a reflection over the x-axis, we have a vertical stretch by a factor of 3, a horizontal shift left 2 units. So this is a decay function because our b is less than 1 but greater than 0. And since we don't have a vertical shift, our horizontal asymptote is y equals 0. So you plot our horizontal asymptote, and hopefully the points you got from your calculator, these were the best points I could find. So you plot those and you use the calculator to help you sketch your graph. So let's talk about these. As x approaches positive infinity, as we follow our graph to the right, our graph is getting closer and closer to 0. So it approaches, f of x approaches 0. As we follow x to the left, our graph is going downwards, so f of x approaches -infinity. The domain, we will have all values of x and y to the left and right. Since our graph goes down forever, our range, the lowest value, will be -infinity. And then for the highest value, it gets closer and closer to 0, but it doesn't reach there. So we're going to say our range goes up to 0, but not including it. And so hopefully you got this right. I'll see you in class for more practice.